Hello everyone, welcome to this video. In this video we'll be solving this question which states that if G be some group of polynomials under addition with coefficients taken from Z10. So how is that group? So that group would contain polynomials of this kind: an x raised to power n, an minus 1 x raised to power n minus 1, an minus 2 x raised to power n minus 2, so on up to a0, right? You can say a1 x raised to power 1 and then a0 x raised to power 0, which is nothing but a0 only, right? Where all these coefficients an minus 1, an minus 2, a1 up to a0, they all are taken from Z10. So that means they are only the numbers which are starting from 0 and going up to 9, right? And for the calculation for the addition, we'll be using this operation addition modulo 10. Why? Because we want the coefficients to remain within this group, and they would be remaining in this group if we apply this operation of addition modulo 10 onto it, right? This is the first thing that you should note. Further, we need to find the orders of these three polynomials. First is fx, second is gx, and then third is fx plus gx, which is also given to us. So here, in order to calculate the order, you first of all should know what is the identity of this group. So the identity of this group is the 0 polynomial, which is 0 into x raised to power n plus 0 into x raised to power n minus 1 and so on, plus 0 into x plus 0, right? So how can we calculate the order of an element of which is a polynomial? So here, because we have addition, so that means what is the smallest number of times we have to add fx to itself so that we obtain the 0 polynomial. So you can write it in this way: n into fx is equals to the 0 polynomial. So we have to find what is this n in each of the following cases. So in the first case, when your fx is this 7x square plus 5x plus 4, in this case the order is 10. Why? Because if you multiply this by 10 or you add this polynomial to itself 10 times, you would have 70x square plus 50x plus 40. However, the coefficient 70, 50, 40, they should be present in Z10. Right. So what we'll do in order to make them present in Z10, we'll divide the coefficients by 10, and whatever is the remainder is your answer. So when you divide 70 with 10, you obtain 0 as the remainder. Similarly, when you divide 50 with 10, so you have 0 as the remainder, and similarly when you divide this 40 with 10, you have 0 as the remainder. So in each of the case, you have obtained this 0. Finally, you obtain this 0 polynomial over here after applying this operation of addition modulo 10, right? So therefore, in this case, the number n is this 10, and that is the order of fx, right? Similarly, we'll be calculating for gx. For gx, we have 8x square plus 4x square plus 8x plus 6, right? Here you see the smallest number of times in which it is added so that we obtain the coefficient as multiple of 10. Why? Because we wanted to take mod 10 of it such that we obtain 0 here. So that means these coefficients should be divisible by 10. So that is what we are seeing here. We are looking for some number such that we multiply whole of this polynomial such that all the coefficients are multiples of 10 in this particular case. So therefore, in this case, we have 5 into 4, which is 20, 5 into 8, which is 40, 5 into 6, which is 30. When you divide 20 by 10, 40 by 10 and 30 by 10, in each case you obtain 0 as your remainder. So therefore, you obtain the 0 polynomial, hence 5 is the order of gx. In a similar manner, the order of fx plus gx is 10. Why? Because when you multiply this by 10, you obtain 10 and 30 as the coefficients, which on dividing by mod 10 give you 0 as the remainder. So the order in this case is 10. Next part of the question here says that if you have hx as some polynomial a x raised to power n plus a n minus 1 x raised to power n minus 1 and so on, we keep on doing like this until we reach the constant, which is a0. Right? If this polynomial is the member of this group, then we need to determine the order of hx when we are given the 4 cases. In each of the 4 cases, we have to tell what is the order of h. In the first case, the GCD of all the coefficients is equal to 1. This is given to us. So let's move ahead and see this case. When the GCD of all the coefficients is 1, So that means they do not have anything in common. So how can we obtain the zero polynomial? The zero polynomial is obtained when you have each coefficient as multiple of 10. And how can we obtain each coefficient as multiple of 10? Whenever you divide that by 10, you have a complete division. That means 0 is the remainder. So that means each should be a multiple of 10. How it would be a multiple of 10? When we will be multiplying it by 10, right? Why? Because we cannot have 10 as common, because the GCD of all of them is 1. They are all co-prime to each other. Hence 10 is the order in this case. Similarly, if the GCD of each of these polynomial is 2, in that case, what do you mean by GCD? They have 2 in common. So if the coefficient A0 is 2 into some number, A1 is 2 into some other number, say B1, A2 would be 2 into B2, right? B2 is some other number, and so on. AN would be 2 into Bn, where all of these numbers B0, B1 up to Bn, they do not have anything in common. So that means their GCD is equal to 1. In that case, your order of hx is 5. Why? Because when you multiply 5 with this polynomial, so in place of an you can write 2 times of bn. In place of similarly an minus 1, you can write 2bn minus 1. Similarly for a0, you can write 2b0, right? Then you can multiply this 5 inside. So you see, when you multiply by 5, each of the coefficient now becomes the multiple of 10. Right? And when you take the multiple of 10 dividing by 10, you get 0 as the remainder, right? So therefore in this case, this is the identity element, hence 5 is the order of hx. Similarly for the other two cases, when the GCD of the coefficients is 5, then you can write a as the multiple of 5. All the coefficients a's could be written as 5 into some multiples of 5, say 5 into the coefficients b's, where all the b's, they have GCD as equal to 1, right? They do not have anything in common. Then we would say the order of hx is 2. Why? Because when you multiply 2 with this polynomial, so writing instead of an the values 5, bn and so on, when you multiply 2 inside, you see every coefficient becomes multiple of 10. So when you take its mod 10, you would obtain the zero polynomial. Hence the order is 2 in this case. And similarly for the last case, when the GCD is 10, then you can write each of these coefficients a's as 10 into some other coefficient, such that the GCD of these other coefficients is 1. In that case, the order of the polynomial hx is equal to 1. Why? Because when you multiply 1 with this polynomial, then in place of these an's, you can write the values of bn's, right? Once you write the values of b's, then you obtain the zero polynomial, correct, when you take its mod 10. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.